All right, looks like the room's a little emptier than it was a minute ago. Next up, we have Jean-Marie Verdun talking about expanding the server lifecycle.
Hi, my name is Jean-Marie. I'm French. As you can hear, my accent is quite high. I'm going to speak about a subject which might look like a little bit strange within the high-tech industry. So how can we expand the life cycle of our product? So normally we're super excited by new products, and we're not thinking about what's going on with the old one. So what I think is that there are a couple of opportunities regarding expanding product lifecycle in open hardware for various reasons. The first one is when we look at the CPU performances during the last decade. So the Xeon 5470, which was designed back in the 2000s, 2005, something like that, and look at the latest V4. I'm not speaking about Skylake, but the raw performances of the single core didn't evolve that much. It's about 30% during a 10 years period. That's nothing compared with what happened back in the 80s and the 90s, where we were doubling the performances of the CPU every year. So the performances are improving based on the number of cores and the I/O subsystems. So where the progress has been made is mostly regarding DRAM access, memory bandwidth, and latency, and how many cores can we stick within a single CPU. So, and based on that, we think that some servers which have been designed 3 years ago can still sustain some very interesting workload because their single core performances are pretty close to what's going on with the current designs. And there is another aspect for hardware design which is quite interesting. This is the lifespan of the I/O subsystem. So PCI Gen 4 has just been introduced, but for many years we kept PCI Gen 3. So when you think about the OCP design, the first generation of servers, Xeon, even the Xeon V1 and V2, were supporting PCI Gen 3. So if you have an I/O intensive application, this kind of CPUs might be still super efficient. And there are some opportunity there to keep using this hardware. There is another trend within the industry is that when we deploy server in data centers, they are designed for one use case. So when you look at the rack level system integration, so there are racks filled with compute nodes, there is storage infrastructures, web front end, big data analysis solutions for Hadoop, and all these kind of things. So the hyperscalers are really thinking about picking up racks, dedicating the use case to either compute or storage, and then decom that rack. So, and what are the real issues regarding that? When we look at the lifespan within a data centers, the life cycles is super short. And that's not because people are really super excited by new technology, but there are some constraints about launching new services and acquiring technology which are adapted for these services. And building a new data center takes more time than acquiring new servers. And that's the other biggest challenge that we are facing. And when the servers are decommed, so right now, they are recycled. They are not recertified, they are not reused. And recycle means they are dismantled, and we reuse the raw material. And we try to have some process to properly recycle without generating too much waste. But it's mostly super difficult process, especially at the PCB level, because the chemicals which are contained within the PCB are really hard to recycle and to get out from them. So we started to launch a program to understand if open hardware can bring some value, and are we able to pick up a server from the data centers, recertify it, and look at what kind of features we have to upgrade from this machine to keep it up and running and being able to be reused somewhere. So the first thing is that we discovered that there was a lot of security issue when we are picking up an old systems, because the system BIOS or all the low-level firmware are no longer supported by the ODMs or by the industry. And we thought that this was really key, that we can upgrade this low-level software to bring the the safety that an end user is expecting. So that's also why we launched the Linux boot project, which is an open BIOS implementation that you can see on the Facebook booth currently up and running. OpenBMC is also a very good alternative against security threats. So that's an open source project that you can stick on the BMC. And we are porting all of this software stack on the edging servers just to keep them up and running and enhance the longevity of the firmware. There is also another benefit for open hardware regarding open design is that when you know how the server works and if something breaks at the VRM level, so most of the time when the motherboard dies, that's coming from a dead capacitor which dried out. That's a component which costs about, what, 10 cents? And you are scrapping a motherboard which costs a few $100s just for a 10-cent component. So if you know the design, you can repair the board, and you can keep it up and running. So that's also the main benefit from open hardware. And what we have seen lately is that we can transform a compute node to a new kind of systems, like networking servers or storage solution, purely because the I/O subsystem is good enough and is still performing at the same level of performances than new hardware. So why using a new servers for a storage solution, a cold storage solution, if you can benefit from an edging one, and how can we transform that? So what we think also is that at the rack level, so we were scrapping a lot of racks. So why scrapping racks? They are still good enough to be run in production. And we see that open hardware can really enhance the life cycle of servers. When I'm running this talk, most of the people are always telling me, but new processors are consuming less energy. So what's the real carbon footprint of that theory? So what we all must think about is when we produce a new systems, there is energy which are required. And whatever happened, and the amount of energy is quite high. It's about 6,000 megajoules right now. So that's a lot of energy. And when you dismantle a server, you still need some energy just to move the racks outside from the data centers to a recycle area and just to recycle the parts or welding the steels and whatever. So we estimate that around 1,000 megajoules for each unit. And when we look at the energy balance, and if you have an average workload which is equivalent to 70% of a Xeon V2 CPU, and you apply that workload with the spec-in benchmarks related performances gain that you might expect from the new servers, you can see that an old Xeon V2 systems has a better carbon footprint than a new one, at least during the first year of operation, if your workload is equivalent to something like 70% of the machine. So that number is really key. So depending on the workload profile, so if you have a workload profile which is requesting low CPU requests, like a mail servers or print servers or anything which is related to daily human activity, and so when we sleep, we don't use computers. So edging servers have a better carbon footprint, so which means that it can be really efficient to try to keep them up and running as long as we can. So could it be the reason why open hardware might be successful? There is a huge debate in Europe about open hardware currently. So as I told you, I'm French, and currently we have in Europe a vision about open hardware which is a little bit different from North America. So open hardware means that we can replicate by ourselves the design and we can get access to everything. In the US, we see a trend where people are more thinking about standardization and getting access to API interfaces to the hardware. So that's slightly different in Europe. But what we see is that if the design is really open, and if we keep the design really open, we can really create a new business model around IT infrastructure. And that new business model means extending the life cycle of the servers, reducing the carbon footprint of the industry, and generating less waste. So one of the goals we can sustain with open hardware is just to avoid that we generate a lot of landfill hardware somewhere in Asia or somewhere in Africa, in emerging market, which are repurchasing DCOM machine just to get access to the key high-value elements which are standing within the hardware and doesn't know what to do with the low value, and this is ending up in high landfill. So that's something we need absolutely to avoid, and that's also why we are working on that project. The key things also with the recertification program we are trying to put in place is can we mix recertified hardware with new hardware? So that's a good question. So when we design a new servers as a community right now, we are redesigning everything from scratch, if you think about it. Even the chassis or the racks or whatever, even if it's improving the performances and the global performances of the systems, in some cases we might be thinking more about how can I reuse the previous racks, or how can I use an Open Rack V1 between a Skylake machine and a Xeon V1 servers? Can I keep compatibility or not? And what is the real value I will get if I'm erasing the past? So this is all the debate that we are willing to have with the community right now. And the other things is there is within the OCP designs a lot of options which are available. And when you think about the options, I'm going to speak about the Winterfell servers. Who knows the Winterfell servers in that room? OK, nobody. So the Winterfell machine is the Xeon V2, which is used by Facebook within their data center. So that's a dual socket Xeon system. But that machine has been designed with, there is a SAS options on the chipset. And everything has been routed by the ODM, but there is not the connector there. So which means that we cannot convert the compute node to a storage node purely because it's missing one connector which costs a few dollars. And that's really frustrating, this kind of, it's not a mistake because the design has not been thought in a way that we can reuse the machine and we can think that the machine might have a second life. But this is really hurting us currently because these kind of small features could really add some value to a machine which is considered as end of life within hyperscale data centers, but which can be really good as a secondary market. So if you design system and if you think that an options should be an option, keep in mind that how can you integrate that option 3 years later or 5 years later. So that's really key if we want to have a more sustainable IT industry. So that's what we are seeing. What is needed to be successful within the recertified or extending life cycles of servers? We really need open servers because when the machines are considered as dead within hyperscaler data centers, so it means that they are end of life from the ODMs. So there's no longer any system BIOS support or BMC support or even hardware support. So if it's not open, a small team like us or any community members who are willing to fix an hardware issue or a software issue on the machine cannot do it. So we need to get access to schematics. We need to get access to the Gerber files or even the BOM. So that's really key. And if we can get access to that, so we might be super efficient at extending the life cycle of the machine. And there is a strong demand for that, and there is a very huge market opportunity. What we think also is that we should start thinking more about building block designs when we have servers. And what I mean by building block is designing motherboard with a very few number of options which are preloaded on the board, and try to think at how we can convert a compute board into a storage solution, then a networking solution, or a very basic infrastructure solution after 3 years, 6 years, and perhaps 9 years. And if we can do that, that might be super efficient to keep the server up and running. I shouldn't say forever, but at least for 10 years. So I used to work for Digital back in the 90s, and my first computer was a VMS machine. I don't know if you have known that operating system, but the machine was up and running for 10 years. So who knows a system which has been up and running for 10 years based on Linux right now? So there's not that many systems like these ones. But I really think that open hardware can help to have more machines like these ones. And that's really key. Then there is that debate. We have such dedicated features into the servers, which are compute or storage box, that we are ending up to be into a deadlock when we try to convert them. And that's an issue. And that's, we believe that if we work as a community, we can fix pretty easily this issue, having a more general purpose design that could be extending later on. And we met a couple of issues like PCI bifurcation implementation into some servers, so which were a little bit painful to address. So because we didn't get access to the info, and we have to run a lot of reverse engineering to expand the life cycle of this machine. And it might be super if we can avoid to reverse engineer systems, and we can rely on high quality documentation from the original design team. And then after, we have to address the part availability. So if you think about expanding server life cycles, so what's going to happen is a small part, which was a super idea when we launched the design, is going to be end of life 1 year later or 2 years later. You don't care when that server life cycle is 3 years, but you are more caring about it when it's 6 or 5 to 10 years. You still need to be able to service the machine. And when you think about the design, I really think we must sort out what kind of part we are going to rely on. Is this going to be available long term? Is this really new? Is this really useful? And depending on the answers of all of these questions, we can decide as a community to use it or not. So I can give you a quick example. For example, just the mezzanine card, which is using a PCI X 8 lanes for the V1 of the mezzanine card. If you want to swap this connector currently, it's super hard to source because it's no longer manufactured. You need to find some alternatives. So all of these things which are super efficient at the original design might be really painful later, and we need to avoid to use this kind of trick. I have finished my talk. My intent was really to try to motivate you to think about when you design a machine and when you are going to use a machine, what's going to happen when it's going to be decommissioned. And what are we thinking about what should be the life cycle of the systems, and is there some opportunity to reuse that machine later on? And if there is one, what can we decide at the early stage of the design? So that's really a key thing. What we see is we started that project about 1 year ago. So we decided to have a look at what's going on decom systems. And we say, can we reuse them? And everybody was thinking we were crazy about that. But quickly, we started to work on a recertification program, and we shipped hundreds of racks from decom systems to new customers. And these new customers are not in emerging market at all. They are in North America and Western Europe. And they are super happy to reuse decom machine because we just changed the way they were designed for to a new features, a new function. So, and we are quite successful at transforming a compute machine to a storage box, as an example. And what is really key is that you probably know the Lightning project, which is an NVMe storage box from Wewin, which is used by Facebook, and you can see it on Facebook booth, by the way. So that box is interconnected to a storage machine, which is roughly just a network connection to the NVMe subsystems. So roughly you get some servers which are clients to the NVMe box. So when you are customers, you are willing to put your US dollars into the storage solution. You don't want to put the US dollar into the server which is used to attach the box to the network. So if you can use if you can reuse an aging servers just to build up a fast NVMe chip solution based on an existing servers, that's a very efficient way to build up a new storage configuration and discover NVMe. I'm done with my talk. I don't know if you have any question. What is really key, just as a conclusion, is that we get open source firmware to be successful within that program. And Linux Boot is something we are really involved into it. That's a joint project between us, Google, Facebook, and a company called 2 Sigma on the East Coast. And the intent is really to have an open platform for the system BIOS, which is really key to provide high security. If you want to see a demo, so we have a live Linux boot system on the Facebook booth on an engine servers. So that's a decom machine that we recertified, and you can see it up and running, and you can even taste the performances we can get out of that. So feel free to come to the booth and join us. Thank you.
All right, thank you very much.